These are the curves we should end up with on our model. So the first one is the center axis, which is this green line down here. So we might find that useful. The second one is the center area, the center hub section. So that's the light purple there. So you can see there's a surface or a curve on the front and one curve on the rear. This rear surface here we can build from the dimensions, we should build from the dimensions of the geometry. So we can take that from the center line here, and we need to offset that by 49 mil. The easiest way often to do this sort of thing is to pick the curve that we want to reference to, and then there's two possibilities here. We could do Control C, Control V, and then move that. So if we now move that, and in the user prompt area we can put in the movement that we want relative to where we are. So if we tab into that area, you can see it now highlights in darker in black rather than grey, and then we type in the distance we want to go. So we want to 0 in the X direction, minus 49 in the Y direction, which is along the axis, and then Z is also 0. So that would give us that copy of that line, and then we trim that up to create that back face of the center hub. So I'm just going to delete that to get it out of the way, but that's how that line is created. So that's the center hub. The second bit is the second part there is the bolt hole, so that's the area in blue. Again, we can use the center axis as a reference here. You notice it says PCD 120. PCD is pitch center diameter, which means that that's the diameter of that axis through the bolt hole. In other words, the radius is going to be 60 mil, so we want to copy this axis line up 60 mil in the Z direction. So we'll do that a different way. We could use Control C, Control V again, but I'm going to do it a different way. If we go into Edit, Duplicate Object, here we can put in the number of copies that we want, which is 1. We want to make an actual copy, and then we want to translate it by a certain distance in the Z direction. So we want 0, 0 in X and Y, and in the Z direction we need the radius value, which is 60 mil. And then we press go, and then we've got the copy. So that's another way that we can create these lines. And I'm just going to delete that one because we've already got the line in there. And of course we can trim that back to the back surface, the back curve there. Likewise, the rest of the bolt hole, the profile there, we've got a diameter value there of 24 mil and a diameter value there of 38 mil, so we can work out where these lines need to be. And there we've got the 24.5, which tells us how far that line is across. So there's our bolt hole section. The most complicated part is the rim, which is that green area out here. And we've got a mix of actual dimensions. So we've got some dimensions here which we can see that that's balanced about the center line. So there's your center line. So if we divide that dimension in 2, we can get that position. And again, divide that by 2 and we get that dimension. The top corner there we can take from the diameter, and this dimension here, that's actually 17.3 mil, not 7 mil, 7.3 mil. It's 17. There's a 1 chopped off in the image. So we can work out exactly where that spot should be, so we can build those surfaces, those curves. Inside of these points, there's no clue as to what the angles are other than the image, so we've just got to take that from the image. In reality, all of that section will be given to us by engineering. It's only where we get interested in this, where it becomes aesthetic, in the front of the spoke and the rim and the inside of the rim there, that we then have to take over. But we would get that information, that green information there, from engineering. But here we're going to build it all. What you can see here is we've got the block curves, if you like, and then the radiuses here. We're not interested really in making these curvature matched. It's not necessary. They're engineering parts. They're not going to be visible. The only ones that are visible would be that radius there and that one, but we're just going to make those circular arcs for the purposes of the exercise. When we revolve this, we don't actually really want to have these as block curves because they'll generate block surfaces. Normally we would have block surfaces, but for this exercise we're going to just trim them all back. So we want to end up with something like that. So that gives us our rim section that we can revolve, and you notice we've stopped it at this point because in fact that runs into the back of the spoke. So the back of the spoke is this section here. So this one we can take off the image. This curve, you need to make that nice and simple. Just make it one curve. The only critical thing about that, so we haven't followed the image exactly, it's not necessary. We want to create something that we like the look of. The one critical dimension that we need to respect is this dimension from the brake caliper package into that corner there. So if we measure from there to there, we want that to be 4 mil at least, and we've got it at 4.05 there, so that's fine. So you need to watch that, make sure that that's kept, but other than that just keep a nice simple curve through there. And then we've got a blend in that corner, and that should be a G2 blend. So if we look at that one, you'll see that it's degree 5, and you can see those are the CVs on that. So we're going to eventually revolve that orange shape there to give us the back surface of the spoke, but also part of the rim. And then we've got the front area of the spoke, that's the final part. So the front area, that front curve is a freeform curve. We can make it any shape we like really, but let's just keep it simple for the purposes of the exercise. So this one is that sort of shape. We need to be inside that red line because that's the critical overall dimension that we need to respect. And we also need to have a surface, a curve going through here. Again, we don't need to follow exactly the image. The image is just from an engineering section of a previous wheel, so we can create some new section through here which the designer's given us. And then we've got a blend between the two there. So again, that's a G2 continuous blend with degree 5. And there we have it.